So last time we were talking about speed. We defined speed as rate of change of position. So speed is denoted by v. It's final position minus initial position over time interval. And time interval is t final minus t initial. And usually in physics problem solving, we consider the initial time to be 0. Okay? We usually start the motion at some 0 time. So instead of writing delta t, so this is 0, we can just write t. Okay? T itself is the time duration. So we can just write this as t xf minus xi over t. So whenever you see this letter t, it means it's a time duration. So we got that last time. Okay? And this is also the average speed. Okay? So you're walking on a road, okay, and you may have one speed at this point and another speed at this point. Okay? Your initial position is xi and final position is xf, and you may have a bunch of speeds in between these 2 points. So you want to know what's the average speed with which you are walking here. So this gives you the average speed. Okay, let's write this VAV, average speed between initial position and final position. So we talked about speed, but now let's talk about what is velocity. Okay. Velocity and speed are same kind of things, except velocity has direction in addition to the value or number. So speed has only magnitude or number, and if you add direction to that number with unit, then we call it velocity. Okay, speed plus direction. So when you say my speed is 10 miles per hour, you don't need to worry about the direction. You only need to state the number or quantity. But if someone asks you what's your velocity, then you will need to say how fast you are moving and in which direction you are going. Okay, so that's the velocity. Both are same with the difference of direction. Likewise, distance and displacement are also more or less same. One has only magnitude, so distance has magnitude only. There's no direction. And displacement is the quantity with magnitude and direction. Okay. Now there is a little bit more distinction between distance and displacement compared to speed and velocity. So distance is the total length of the path you travel from some initial point to final point. Let's say your initial point is here, we'll call that I, and your final point is call that F. So between I and F, you're traveling like this, okay, through some zigzag path. So the total length you travel from I to F, this whole thing, let's use different color here. So this path you travel, so measure this path with some kind of meter, some kind of scale, measuring tape or something. So this path will give you the distance. And distance doesn't have any specific direction. So you see that each and every point, at each and every point you are changing your direction. Okay, so when you are going this way, so that's your direction. When you're going this way, your direction is that way. Here it's down, here it's that way. Okay, So direction is changing all the time, no one particular direction. So that means we say distance doesn't have any direction. Whereas displacement is the shortest distance between initial and final point. So if I draw a straight line between I and F, it's hard to draw a straight line here. Okay. So that gives me the displacement, okay, shortest path. And I can also say that I am going along this direction, okay, to the east, because I have both magnitude and direction. So it's the displacement. Now there are terms that we use in physics to denote the quantities that have both magnitude and direction, and also the quantities that have only magnitude. They are called vector and scalars. So first talk about scalar. So let's just say scalar quantities. Scalar quantities. So those quantities that have magnitude only. Okay. But no direction. So for example, length is a scalar quantity, because when you measure the length, you don't need to say 1 meter to the north or 1 meter to the south. You only need to say it's 1 meter or 1 feet, 1 foot or 2 feet or 1 kilogram, whatever unit you use, inch, something like that. Okay. Likewise, mass. So when you express mass, you only need the number with the unit. You don't need to worry about the duration. Okay. Time also doesn't have direction. Okay. Temperature. So 32 degrees Fahrenheit, there's no direction, just magnitude. Likewise, we have vector quantities. Those quantities that have both magnitude and duration. Okay. So example, velocity. So when you are driving a car on a road, you need to, when someone asks you what's the velocity, you need to say my velocity is 20 miles per hour to the north or to the south. Okay, you also need to specify which direction you are going. Likewise, force. So when you apply force on something, you're pushing, you're applying, let's say 10 Newton force and to some particular direction. Okay. Acceleration, we'll talk about that in a second. Okay. Momentum. Okay, and more. So when we deal with scalars, you can just use basic addition and subtraction to add or subtract scalar quantities. For example, if you want to add, if you want to add 2 meters to 3 meters, you can just add using basic math, it's 5 meters. Likewise, if you want to add 1 kilogram and 3 kilogram, you can add using basic rule, basic algebra for kilogram. But when you are dealing with vectors, you cannot add them using this ordinary addition and subtraction. You will need to use something called vector addition. We'll be talking more about that in the next lecture. So for example, let's say I apply some force in this direction, let's say 5 Newton force, and then I apply some force in this direction, let's say 3 Newton force. So what's the total force that I applied? Total force. It's not 5 Newton plus 3 Newton. Okay, that's not correct. We'll need to use a different kind of math here. So we'll need to learn vector addition for that. Okay, so we'll talk more about that in next lecture, or maybe not next lecture, in the next chapter I should say, when we talk about force. Okay, so now we'll talk more about kinematics here. Kinematics is the study of motion. So this chapter is all about kinematics. That is, we are studying motion. Okay, so when we study motion, we usually deal with 5 physical quantities. Okay, to define motion, meaning how fast we are moving, how much displacement is there, whether we are accelerating or not. So we have 5 quantities. The first one is displacement, delta x, which is x final minus x initial. Okay. The second quantity that we use is velocity. Third quantity we use is time. Fourth quantity we use is acceleration. Actually, we only have 4, but this velocity could be divided into 2 parts. We can have initial velocity and final velocity. Okay, so we need these things to define motion. So we know that displacement and velocity are vector quantities. That means you need to specify direction. Now in physics, often the direction is indicated by the sign. Okay, quantities. So for example, if you have displacement delta x is positive, you get a positive number, then the direction is to the right. Okay, you are moving to the right. If the displacement is negative, then you are moving to left. Same thing with the velocity. Okay, so v, if velocity is positive, you are moving to right, or in other words, if you are moving to right, your velocity is positive. If you are moving to left, your velocity is negative. Okay, and we'll also talk about the direction of acceleration in a second. Now let's derive some important formulas here that we'll be using to solve the equations on the worksheet. The first one is, we know velocity average velocity is x final minus x initial over time. And we also know that whenever we want to find average, you take the different values and divide by the number of values you are considering. Okay, for example, you want to find the average velocity between vi, I, and f. So you know velocity at this point, and you know the velocity at this point, and how do you find the average of these two velocities? You just add them, right? So take this velocity, add with the second velocity, and then divide by 2, right? Like if you have 2 and 5, the average of these two numbers is add them and divide by 2, right? So the average of this one and this one is that. And also we can write the average velocity as change in position minus time. Okay, so these two are both average velocities. So we can now, because this is average velocity and this is also average velocity, so we can write this term to be equal to that. Okay, so this is like if A is equal to B and A is equal to C, then B is also equal to C. Okay, so that's the math, right? So if that's equal to that and that's equal to that, then these two are also equal. So xf minus xi over t is equal to v final plus v initial over 2. Okay. Now we can get two important equations from this expression, which we'll be using to solve the problems. So you don't need to memorize or remember the formulas for exam. They will be all provided on the back of the exam. But I will show you how to derive that. Okay. So before we derive this, we want to define acceleration. Okay. So let's talk about acceleration. And then once we have the formula for acceleration, we'll come back to that. So what's acceleration? You guys use the term accelerator or acceleration all the time when you drive car. What does it mean by acceleration? Getting faster, yeah, that's right. So faster means you're changing your speed or velocity, right? So you are driving at some speed or velocity. I will be using the term speed and velocity interchangeably. When I do that, remember that I'm not considering the duration. Okay, I don't care about the duration. So you are driving at some speed, let's say 10 meters per second or 10 miles per second, 10 miles per hour or whatever velocity, and then you change your speed to 20 meters per second. Okay, and it takes some time. Okay, let's say 2 seconds. So you're changing from one value to another value in certain amount of time. That's the acceleration. So acceleration is how fast, in layman term, how fast you're changing your velocity or speed. Now, some people get confused between acceleration and velocity. So let me remind the definition of velocity here once again so that you don't get confused. Let me write the definition of velocity also in layman term. So velocity is about how fast you are changing your position with respect to some reference point. Okay. WRT is with respect to something. Whereas velocity is how fast you are changing acceleration is how fast you are changing velocity. So that's the distinction between acceleration and velocity. So if you want to think about the example of velocity, so you're moving away from some wall or something, okay, and you move 2 meters every second. Every second you move away at the rate of 2 meters. So that's the velocity. Whereas acceleration here, every second you are changing your velocity by 5 meters per second. Or in 2 second time, your velocity changes from 10 to 20. Okay? So whenever you see this thing, how fast, we call it rate, okay? Rate of change. So formally we can define acceleration as is the rate of change of velocity with time. In a mathematical form, acceleration is change in velocity. So delta is change in velocity over some time. Okay? Change means whenever you see change, it's final minus initial. Okay? So change is final velocity, let's call that v sub f minus v sub I over delta t. Again, you don't need to write delta t, you can just write t because initial time is 0. So we define acceleration, we got the acceleration. This is one of the important equations that we'll be using quite often. Okay, so let me put that in a box. So very important equation. I can also rearrange this to write this in a little bit different way. So moving this t on this left side, I can write AT is equal to V final minus V initial. Okay, so I'm just moving this to the left. And then I can write this as in terms of V final. V final would be V initial, moving this to the left, V initial plus AT. These two are same equations, just writing in different quantities, in terms of different quantities. Okay. So this is the first equation of kinematics. Now let's go back to our previous expression. So we had this expression xf minus xi over t. Okay. So we have x final plus x initial. No. X final minus x initial over t is equal to v final minus v initial over plus 2. Okay, so that's something we got before. Now we want to use this expression in this expression. Okay, so substitute this expression for Vf here. So when I do that, what I get? So xf minus xi over t is equal to V final is V initial plus AT. Okay, I'm just substituting this by this thing. And then I have Vi here over 2. Okay. So xf minus xi, I can get rid of t on the bottom here. So to do that, I can take this on the other side, or some people like to multiply both sides by t to get rid of this t. Okay. So cancel that and that. So you'll have xf minus xi on the left side. On the right side, so this Vi and Vi is 2Vi plus AT over 2 times t. Okay. So separate these terms. When you separate these two terms, you get Vi 2Vi over 2 plus AT over 2 times t. I'm just separating these terms like that. And you can cancel 2 and 2. So we get xf minus xi is equal to, so this t will be distributed to both these terms. So VIT plus 1/2 AT squared. Okay. This is the second equation that we'll be using very often. So this gives us the displacement delta x. So x final minus x initial is delta x, okay, displacement. If you are asked to find displacement, you will use this equation. VIT plus 1/2 AT squared. And if you are asked to find final position, you can use the same equation. So final position is xf. So xf, just rearrange this equation. So you get xi plus VIT plus 1/2 AT squared. Exactly same equation, just moving the terms from left to right. Okay, these are all same equations. Okay, so that's the second equation, and we have one more equation, and then we can solve the problems. And I will summarize all those three equations later, so that you don't have to worry about where to find the equations. Okay. And you will not be asked to derive these equations. Okay, this is just to show you how we get the equation. You don't need to derive, we just need to use or apply them to solve the problems. So again, let's go back to the same expression that we have. So we have x final minus x initial. Say again, over t is equal to v final plus v initial over 2. So that's same thing that we got before. Now this time, let's use this expression. Okay, we have a is equal to the definition of acceleration. Okay, definition of acceleration is change in velocity. That's change in velocity over time. Okay. Definition of acceleration. We can do the cross multiplication. I can take this t on the top here and a on the bottom. That's the simple math you can do. Okay. Now let's replace this t by this t. Okay, so this t there. So if I do that, I get xf minus xi over v final minus vi over a is equal to v final plus v initial over 2. Again, the math may be a little bit complicated, but you don't need to worry about the derivation. We just need the final product. So let's do the math here. So we have delta x minus xi. So we can take this whole thing to the right side. Okay, you can cross multiply that to the right side. So v final plus v initial over 2, and I'm taking this whole thing, this thing to the right here. So if you have like expression like this, you can take this b to the right side here. Okay, so you can write this as a is equal to b times c. That's what I'm going to do here. I'm going to take this to the right. So v final minus v initial over a. Okay, so x final minus x initial is equal to, so this is in the form of this formula. So we have this formula a minus b, a plus b. Do you guys remember what's this expression? A squared minus b squared, right? A squared minus b squared is a plus b, a minus b. That's something you might have seen in algebra. So this is exactly of the same form. So we have Vf plus Vi, Vf minus Vi. Okay, same kind of. So we can write this as V final squared minus V initial squared is equal to 2 times A. Okay, that's the third equation. So we can write this as delta x is equal to V final squared minus V initial squared over 2A. That also gives us the displacement. I can rearrange this and write in terms of Vf. Okay, exactly same equation but in terms of Vf. So I can write this as 2A delta x, take this to the left, then Vf squared minus Vi squared. We can write this as Vf squared is equal to Vi squared plus 2A delta x. Just rearranging the terms, you can get that. So these are all same. That's the third equation. So let me summarize the three equations now. Okay. And then we'll be using those three equations. So equations to solve motion problems or kinematics problems. The first one is definition of acceleration is V final minus V initial over t. Okay, so this could also be written as V final is equal to V initial plus AT, same equation, just rearranging the terms. Second equation is delta x is equal to V initial t plus 1/2 AT squared. Okay, and the third equation is V final squared is equal to V initial squared plus 2A delta x. So we only need these three equations, okay, to solve the one-dimensional problems. Now when we solve the problems, solving problem means finding unknowns. Okay, so whenever I say solving problems, it means finding unknown quantities. Given some known quantities. Now when we solve the kinematics problems, we'll basically deal with 5 quantities like the ones I mentioned before. So we'll be dealing with displacement, we'll be dealing with initial velocity, we'll be dealing with final velocity, we'll be dealing with acceleration, and we'll be dealing with time. Okay. So in the problems, you'll be given 3 quantities, and then you'll be asked to find the other 2. It could be these 3 and finding these 2, or given these 3, you need to find other 2. So need to know 3 quantities to find the other 2. Okay, that's always true. And we use those 3 equations to find the 2 unknown quantities. So before we apply this, one more thing I would like to show you that was left incomplete before. So let's go back to our here. So we talked about the direction of displacement and velocity. Now let's talk about the direction of the acceleration. Okay, here I will just give you the rule, but later I will explain why those rules apply. Okay, so let me erase something here. Okay, the rule is for acceleration, we can have two kinds of motion. One is speeding up. Okay, you accelerate when you are speeding up. You also accelerate when you are slowing down. When you are slowing down, the acceleration is called deceleration. Okay, you can also call acceleration, but sometimes we call it deceleration. So this is deceleration. And this one is when speeding up, we call it acceleration. Okay. When we are speeding up, V and A have same direction. Okay. So for example, if the velocity, you are moving this way, okay, and acceleration is also in the same direction, the meaning is you are speeding up. If you are moving this way, that's the velocity. But if your acceleration is pointing in the opposite direction, then that means you are slowing down. Okay, that's one rule you need to remember. And I will show you next time why this is true. Okay, we can show that mathematically. So that's the last thing you want to know before we go to the problem on the worksheet. Yeah, sorry, question? Okay. Okay, so let's look at worksheet problem 1. Let's read the question. Those who are on Zoom, let's see, I don't know how to. Okay, I should have posted this on Blackboard. I forgot to do that. So let me just read this question aloud if you are on Zoom, and then I will show you how to solve that. So this question is asking that a ball, as it rolls up a slanted driveway, so we have some kind of slanted road or something, and a ball rolls up that slanted driveway, and it's asking represent the motion of the ball with the particle model showing the velocity vector and acceleration vector. So we want to represent the motion of this with the particle model as it goes up and comes back. So the way to do that is, we use a point or this kind of dot to represent the object, which is a ball here. So it's moving up. When it's moving up, its velocity decreases with the time. Okay, so the gap decreases. It gets smaller, and the distance gets shorter and shorter. Okay, so that's when the velocity is decreasing. And we also need to draw the vector diagram. So vector diagram shows direction and magnitude. So if you have an arrow, this length is the magnitude Okay, how big is the velocity? And this arrow tells us which way it is moving. Okay, if you have two arrows, one is longer and other one is shorter, that means this one has higher velocity than this one. Okay, so here that's the velocity. So it should be pointing that way. Okay, that's the velocity. It's moving up. Now, in the next instance, the velocity will be less, so you need to draw a shorter arrow. In the next instance, it will be even shorter, even shorter, even shorter, even shorter. Okay, draw the arrow pointing up for the upward motion. For downward motion, so let's say it stops here and then returns back, so it will speed up. Okay, that means the gap between these dots increase as it goes down. So you draw the arrow for the downward motion in the downward direction. So that's the arrow, okay, for the downward motion. Okay, so that's the velocity. So v, that's v, direction of velocity. We also need to show the direction of acceleration using the rule I just told you. So when it's moving this way and it's slowing down, when it's going up, it's slowing down. So what's the direction of the acceleration be then? When the object is slowing down, what can you tell about the direction between v and a? Are they in the same direction or in opposite direction? Look at the rule, opposite, right? So if the velocity is up, then acceleration must be down because it's slowing down. Okay. Here, when it's coming back, it's speeding up. Okay, down is speeding up. So now look at the rule again. What's the relationship between the direction of velocity and acceleration when it's speeding up? Same, right? Same direction. So for speeding up, that's the acceleration. Okay. So that's how you represent motion with a particle model. Now let's look at the problem. So it says the ball starts at 2.5 meters per second. So initially here the ball has the velocity of 2.5 meters per second. Okay, that's the initial velocity. And it slows down for 5 seconds. So from here to here, it takes 5 seconds before it comes to rest. Okay, so here, eventually, at the highest point, final velocity would be 0. Okay, let me write it down. So initial velocity of the ball is 2.5 meters per second, and after time t equal to 5 seconds, it comes to rest. Rest means now its velocity would be 0. Okay. So it's asking, what is the magnitude of the ball's acceleration as it rolls up? We need to find the acceleration. So acceleration is, we have the formula for that, final velocity minus initial velocity over time. Okay, final velocity is 0. Initial velocity is 2.5. Time is 5 seconds. Okay, so that is negative 2.5 over 5 seconds, which is negative 0.50 meters per second squared. Okay, we have meter per second here, and there is a second down here. So second and second would be second squared. That's the unit for acceleration. Okay, unit of acceleration. And that makes sense because here in the picture also the arrow is pointing to the left. Whenever the arrow points to left, we have negative sign. Negative sign means pointing to left. Okay, so let's look at number 2. So let me read the question. An automobile starts at rest. So let's say you have a car or something. Okay, it starts from rest. So this is 2. Starts from rest means its initial speed or initial velocity is 0. Okay, it starts from rest and it speeds up at 3.5 meters per second squared. Okay, so that means it accelerates at the rate of 3.5 meters per second squared. The meaning of this is every second, the meaning of acceleration is every second speed increases by 3.5 meters per second. Okay, so at one instance its speed is 3.5 meters per second. After 1 second later it will be 7 meters per second. After 1 second later it will be 10.5 meters per second, like that. Okay, so how far it will have gone when it is traveled at 25 meters per second. So if it is after the acceleration, if its final velocity is 25 meters per second, then what would be the displacement? We want to find the displacement. Okay, so we want to use one of the 3 formulas. You can see which one is relevant. So given these things, we can use this formula. Okay, delta x is equal to v final squared minus v initial squared over 2a. So plug in the numbers. Vf is 25 meters per second. We have square, so put square. V initial is 0. 2 times acceleration is 3.5 meters per second. Okay, so 25 squared over 7. That gives us 89.3. So the unit of displacement is meters. We need to use meter. Okay, so that's number 2. We'll continue this in the next lecture. Okay, so please finish 1 and 2. We'll finish this Friday and then you will turn this on Friday in Blackboard. So that's all for today. If you guys have any question, I can answer your question. Otherwise, we'll see in the next lecture.